In this video, we're going to talk about vectors. The word vector is probably already familiar to you. For example, you may have taken physics classes. Vectors are described as physical quantities that need to be described with both a magnitude and a direction. For example, force and velocity are vectors because actions of the force applied and the velocity matter. The quantities that don't have directions are called scalars. So scalars are the quantities that only have magnitudes. For example, temperature is a scalar. So you may have used the following approach to visualize vectors in physics. For example, to describe a force applied on an object, you would draw an arrow with initial points and a terminal point. The direction of the arrowhead will describe the direction of the force, and the length of the arrow describes the magnitude of the force. In linear algebra, those arrows that represent vectors are called geometric vectors. So a geometric vector is an arrow that has an initial point A and a terminal point B. So here is the arrow. We'll describe this geometric vector as vector AB, where an arrow on top of AB means this is a vector. So a vector that has initial point C and terminal point D will be described as vector CD. So conventionally, if you see a vector being described with two capital letters, for example AB, CD, and then an arrow on top of it, that implicitly means that the initial point of the vector is the first letter and terminal point is the second letter. There's another commonly used notation for geometric vectors, which is to use a single lowercase letter, for example V, and an arrow on top of it. So this notation will omit the information about the initial and terminal points and simply naming the vector with a lowercase letter. So when we draw those vectors, we will simply put the lowercase letter right next to the vector. So an important thing about geometric vectors is the concept of equivalent vectors. Two geometric vectors are said to be equal or equivalent if they have the same length and direction. For example, the vector AB and the vector CD described here are equivalent even though they have different initial and terminal points, because the arrows between the initial and terminal points have the same length and direction.